Today's lesson is on inverse relations and functions. So, for just kind of your intro, if you have a function f of x with point AB, the inverse, the notation is f, it's like to the power of -1 of x. So that is inverse notation. It would have the value be a. So it's basically switching your x and y values. So you're going to see what this looks like in terms of a graph and equations. Okay, starting out, I'm going to look at f of x equals x squared plus 5x minus 7. So that's a quadratic. It's going to graph a parabola. And I'm going to give you some exact points to graph it. So it is, let's see, -6, -1, -5, -7, -4, -11. It does go off this graph a little bit. -3, -13, -2 also is -13, so the vertex is just below. -1, -11, 0, -7, and 1, -1. Okay, so if we graph this parabola, now let's look at the graph of its inverse. So the inverse, easiest way to do this is to just switch our x and y. So -1, -6, -7, -5, -11, -4, -13, -3. Oops, that was supposed to say 13 right there. -13, -2, -11, -1, -7, 0, -1, 1. Okay, so let's graph all of those points. -1, -6, -7, down 5, -11, -4, -13. So we're just kind of estimating here. Oops, that was supposed to go. Nope, that'll work actually, sorry. -11, -1, -7, 0, -1, 1. I did not draw that very well. Okay, so there is the inverse of the original. So the question is the inverse a function? Well, if we remember back, probably Algebra 1, pre-algebra, just learning what is a function, we did the vertical line test. So looking at just the blue function, you draw a vertical line, we only cross it one time, only cross it one time, only cross it one time. Now, with the red function, I'm going to cross it twice. So the red function is not, the red graph is not a function. And we could have answered that question without actually graphing it by simply doing the horizontal line test. Horizontal line test we could have done at the beginning. If the original graph, if I draw a horizontal line and it crosses twice, it automatically means the inverse is not a function. And what happens is the inverse graphs they're actually a reflection over the line y equals x. So this example is really just to show the visual of flipping the x and the y and how the graphs reflect, and that horizontal line test. So if you draw a horizontal line, you can determine if the inverse is a function or not. Okay, now I'm going to give you a function and we're going to find its inverse. So f of x equals x minus 1 over x plus 2. And what I'm going to do is actually just rewrite that with y. So y equals x minus 1 over x plus 2. Well, the inverse is when we switch x and y. So that is what I'm going to do in the equation, is just switch x and y. X equals y minus 1 over y plus 2. Now the idea is I now need to solve for y. So you switch x and y and now solve for y. So to do that, I've got this fraction, so I'm going to multiply both sides by the denominator y plus 2 so that those cancel. On the left, I will distribute. So I'll have x, y plus 2x equals y minus 1. I'm going to get my y's on the same side. So xy minus y, and I'm also going to then subtract the 2x to the other side, so negative 2x minus 1. So now that all my y's are on the same side, I'm going to factor a y out. So y out, I'm left with x minus 1. And now I can divide by x minus 1. So y equals negative 2x minus 1 over x minus 1. And to write it with the proper inverse notation, that would be the inverse of f of x is equal to negative 2x minus 1 over x minus 1. Okay, let's do another example. So this time f of x equals the square root of x minus 4. Also written as y equals the square root of x minus 4. To find the inverse, let's switch x and y. So x equals the square root of y minus 4. And now solve for y. So I can square both sides. So x squared equals y minus 4. And then add 4 to the other side. So y equals x squared plus 4. And then to put it into proper inverse notation, so the inverse of f of x is equal to x squared plus 4. Okay, the last example is now I'm going to give two functions and we're going to prove that they are inverses of each other. So if I have f of x equals 6 over x minus 4 and g of x equals 6 over x plus 4. And what we're going to do is function composition. On this side, we're going to do f of g of x, and here we're going to do g of f of x. And the rule is if this on the left equals x, and if on the right it also equals x, then you prove that those two functions are inverses of each other. So let's do that. Okay, f of g of x. So I have to plug in g of x into f of x. So I have 6 over, and then I'm plugging in 6 over x plus 4, and then minus 4. Okay, well, right away those 4's cancel. I'm going to rewrite this as 6 divided by 6 over x. Now I'm going to keep change flip 6 times x over 6. Those cancel and I'm left with just x. Okay, that's a good sign. Now we have to go the other way. So now I'm going to plug in the f of x into the g function. So 6 over, instead of x, it's 6 over x minus 4, and then there's a plus 4 out here. Okay, so if I rewrite that 6 divided by 6 over x minus 4 plus 4, and then keep change flip 6 times x minus 4 over 6 plus 4. 6's cancel, so x minus 4 plus 4, those cancel, and that equals x. I guess I should have all my equal signs on here. Okay, so both compositions get me x, so I just proved that these two functions are inverses of each other. So there's your lesson on inverse relations and functions. Good luck with the lesson.